Okay, ladies and gentlemen, thank you for joining me to do our lesson on the distributive property. This is what your note sheet looks like. When we're all done filling it out, we will be cutting and taping it into our notebook like we normally do together. So starting us out here in the top left-hand corner, the distributive property reminds us that we are going to be able to multiply each term on the inside of the parentheses by the term that is on the outside. So I always tell students to draw this dot right here in between this number, which is tight up against this set of parentheses. Yes, you have a math problem in the parentheses, but usually you can't add these two items together. B's are separate from C's. So that means the only operation that can be taken care of is the A times the B, and this is what it could look like, and the A times the C. So sometimes we write out our answer and we have the dots in between our multiplication of our variables, but most of the time we just stick the AB together and then we have our AC. And again, there's a plus sign between this one because originally the relationship between the B plus C was addition. So we draw arrows, so I think in this arrow we should write down that we should be drawing arrows because the arrows will always remind you that you are taking this number on the outside and you are making sure to multiply through to both numbers or both values inside the parentheses. Think about distributing papers, okay? When Mrs. Vandenberg and I hand papers out, we distribute the papers to each student in the classroom so we all have a copy. And this is what it looks like in math if we just use variables. Most of the time in math, like you've seen before, we use variables, but we also use constant terms or regular numbers. So if we come down to this portion of the paper, I'm just going to block that bottom part out for a second because I want to focus on this first problem. If we have 3 and then we have parentheses x plus 5, we cannot add the x plus 5 together in the problem because you guys know that we can only combine x's with other x's, we can only combine constant terms like number 5 together with other plain numbers. So that's why we're using the distributive property. We use the distributive property so that we can simplify the problem to create something that is equivalent. So equivalent, remember, is just a fancy word for it being equal. So I'm going to start out by reminding you to put your dot here, reminding you to draw your arrows. The arrows will remind you that you're multiplying the 3 times the x. We can write that here. And then you'll see this plus sign that goes in the middle of the problem, and then you'll remember to be multiplying the 3 times the 5. So guys, this takes up an awful lot of space, so typically we don't write this step. It's what we think of in our heads. So the short answer to this is 3 times x, so we'll just write it 3x. And then of course 3 times 5 is 15, so we put that here. This would be the nice, neat, easier expression that doesn't take up any more space, or it actually takes up less space than this one. So this one's pretty straightforward. You may have seen questions like this last year. So I want to introduce you to this one. This one has a -4. You are going to be distributing that -4 into this term and this term. But remember, when you have subtraction in any of our problems, you're allowed to do, and I actually encourage you, to do your keep, change. This makes sure that you realize, yeah, this is a -4. This is a -3. And when you're doing your multiplying, yeah, you're multiplying -4 times the 2y, and you're multiplying that -4 times a -3. So this is what it would look like. This is the operations that's actually happening. Typically we don't write that down, we write this down because -4 times 2y is -8y, -4 times -3 is +12. And I made a little note over here because I need you to remember, when you have a negative number times another negative number, you actually get a positive answer. So please remember that. Positive times negative is negative, but a negative times negative is positive. So down below, what we have is a big kind of messy expression. I'm going to take this work away so we can work on it together. I'm not quite sure why I have it already done up, but we're going to start fresh together. So, first thing I would like you to do is, in this little starburst thing, we're going to remember that simplifying is kind of like sometimes when we would do our PEMDAS problems, okay? If you have parentheses, you would try to do the work inside the parentheses, but in this case, we can't take a minus 4. A's only go with A's, numbers go with numbers, okay? But we still have to use this parenthesis because it involves distributing. There is a number directly outside. That number is actually a -3, so do your keep, change, change. And then while you're at it, please do your keep, change, change down here so that we don't forget. This is really a -4. And you will be multiplying everything in these parentheses first. So you're ignoring the A day, you're ignoring the 2, you're coming way down here to draw your arrows. And again, you are simplifying this first step by distributing. So we would get -3 times A, and then we would do -3 times -4, which is +12. Now, like all the other problems we were doing, you're going to bring down the other parts and pieces of the problem. And this should look familiar to the problems we were doing last week. You can underline these, you can get your highlighters out, whatever it takes to organize your thoughts so that we can work on these correctly. AA, remember this is the same thing as having a plus -3. AA combined with -3A is 5A's. And then remember, you could always take your highlighter if you really wanted to. It's a good idea to put a box around your constants, or in this case I'm circling. So behind the 5A answer, we're going to have a +14 because, of course, 2 and 12 can combine. So having this big messy expression can mathematically be kind of worked on, simplified we call it, so that you're distributing and you're combining like terms like we worked on last week. Now, this side of your paper, we're going to do a couple problems together. I'm going to have you pause the video, and then you'll be able to work on a couple more independently before we check our answers together. So starting at the top, remember the number outside multiplies against everything on the inside. So we've got 9 times 2x is 18x. 9 times that 3 is 27. Now some students get caught up with this minus sign, so if you like, you can do this. But it just means that you will be writing down 18x plus -27, since 9 times -3 is -27. These answers are the same. We talked about that last week if you remember. So again, this time we're multiplying by a negative number, so be careful. We have -5 times 3x. And then what we should probably do is take care of this subtraction sign so we don't lose what we actually have over here. This is -5 times -8. So we will end up with a +40 for our second term. Again, this would be the most popular answer because it takes up the least amount of space, but this is still correct. Okay, so we've talked about basic distributing. We've practiced a couple of those, and if we look a little bit below this, we are going to see lots more practice problems. These ones, remember, are going to involve distributing, but you will also be combining like terms, and you can't combine like terms until you've taken care of your parentheses, just like in PEMDAS. So starting here, we have a +3 this time, so that's going to make 3 times x, 3x. And then back here, we actually have a -6 if we do our keep, change, so 3 times -6 is -18. And I'm going to bring down my 2x now since I'm done distributing. And then you can underline these or highlight them so that you can remember that your 2x plus your 3x gives us 5x's. You still have that -18 that you can't do anything with, so it comes over. Remember, you're going to have mostly 2-part answers for this section. So we'll do one more together. We have a -18 plus 2. There's parentheses, so it means I'm going to be distributing. Again, you're dealing with a +2 times 3t, and that's again 6t. +2 times 9 is 18. And again, we have to bring down that first term that we kind of skipped over so that we can distribute. And now you can put those together. So we're looking at -2t plus 18. And actually, guys, I think we're going to do one more together. This one's tricky because we have subtraction here and here. And that means we are distributing, see where the parentheses are? We have this -5, which is directly outside. So that means we will be getting -5 times h, which is -5h. And then -5 times -7 is positive 35. So a lot of kids don't see the negatives, or they don't do the keep, change, and that's something I need you to look for. Again, we could do our keep, change down here if it helps you. So 9h's plus -5h's is 4h's, and of course we have our 35. So, now that we've gotten past that one, I'm going to need you to take a look at the remaining problems. I'm going to need you to try them. Always, always, always being careful of who's positive and who's negative. And then also making sure that you are distributing first. That has got to be done in all these problems before you can even think of combining like terms. So go ahead, pause the video here. When you're ready, you can hit play to check your answers. Just take about maybe 3 minutes to see the parts of the questions below that you can do on your own. And then press play so that we can check our answers. Okay, so now we're back to check our answers, and I believe we had already talked about these three together, so we're going to come down here to this question here. This is the one where I suggested you change this so that it's a -3 you're distributing. That gives us -3w, and it gives us a -9. You can see I wrote with a red pen here first. And then I brought down my 10 and I brought down my 7w, but I really wanted to do keep, change again so I wouldn't forget that this is really -3w and this is really a +9. And then it looks like I just used my green marker to highlight the w's. That's where I got 4w. And it looks like I put a box around my constant terms. That's how I got my +1. Let's see, the next one also had a -2 that we did keep, change on, so we wouldn't forget to distribute. And it looks like I did my keep, change back here, so I wouldn't forget that that 9 is also negative. So that's how I got this -6c and +18. Just brought down these first two terms. And then I went to combine my c's. I got -1c. And then I went to combine my constant terms. I got 25. Remember, we don't automatically have to put in this 1. A lot of times we kind of leave it so that it's invisible, like this one. Alright, so this last problem, I wrote it a lot bigger on my screen here because I write big and it takes up a lot of space, and I believe yours, hopefully you'll be able to fit yours on your paper. So with this -2 that has to be distributed, I did my keep, change so I wouldn't forget. I got my -6p, and then I have a -8. I brought everything else down, and then as you can see, I have 1, 2, 3 terms that are p's. So these are all getting combined together, and I believe that gives us -13p. And then I believe we have a constant term of +1 and this -8 that gives me -7. I don't know if you can see that on my screen, so I'll try to adjust it. And there it is over there. So we could write it this way, -13p plus -7, but most of the time we do this, -13p minus 7. So guys, I think you know what to do. If I have a picture here, I'll show you. Your note sheet is going to go in your notebook. You're going to cut right down through where the dotted line is, and you're going to go ahead and make sure you are taping on page 39 and 40, please. When you're done with this, I believe you have a maze to complete and homework for tonight. Thank you. Good luck.